I know Mrs. Ziggy does. I don't ever do it. To me, it's never more efficient. So even though you should know elimination and substitution for basic systems, which is what we'll start with here, once we get to 3 variable systems, I will be doing all elimination because it's just way cleaner. And it's much clearer to teach and see, and it's just more organized. So we will solve this system just to review both methods. In elimination, you want to keep things lined up, and these already are. The x's over the x's, the y's over the y's, the numbers over the numbers. What you have to get is the same number either in front of the x's or in front of the y's, whichever is easier. So if you were getting the same number in front of the x's, they would both need to be a 6. And if you were getting the same number in front of the y's, they would both need to be a 2. And I don't care about the sign. I don't know if Mr. and Mrs. Hill do or Mrs. Ziggy does. I don't care if they're opposite signs or the same sign. I address that in a different way than a lot of Algebra 1 teachers do. So one could be a positive 6, one could be a negative 6, or they both could be positive 6s, or they both could be negative 6s. I don't care. But regardless, what's easier here? To get these both to be 6s or to get these both to be 2s? The 2s. Because we only need a multiplier. Now, it doesn't really matter. It's not that big of a difference. I will focus on the 2s, though, or the y's, and I'll get them both to be 2s. So the first equation I have to multiply by 2. Now, the biggest mistake I see is people not multiplying every single term by 2. Usually they forget to multiply the constant 5 by 2. That's a big mistake. The second equation already is a 2y, so I'm not even going to touch that. And then here's my little saying. If I have opposite signs, add. Same signs, subtract. And the same sign subtract works well because it's an alliteration. Yes? We all know what an alliteration is. SSS. Okay, so same sign subtract. What I mean is on the 2s. If they're the same sign, then I would subtract, because if they're the same sign, then they're the same number, and anything minus itself would give you 0. If they're opposite signs, which these are, you add. And that's going to determine what you do for the whole thing. So I'm going to add, add, add. I put the addition sign in all 3 spots, because one of the more common mistakes I'll see is if people just put the plus sign out in front, they forget to do it for every single set of terms. Really happens more often when the subtraction is what you chose, but regardless, I put it in between every single term. So now these two, the 4x plus 3x becomes a 7x. Negative 2y plus a 2y eliminates, hence the title of the process, and 10 plus 4 is 14. So we just get x equals 2, and then we kind of domino effect backwards. 3x, oh no, not x. I'm replacing x with 2. So 3 times 2 plus 2y equals 4. I can subtract this 6 from both sides, because essentially that's a 6. And y equals negative 1. So if I were to graph these two functions, this would be a line, this would be a line, and this would be the point where those two lines cross. We know that, right, from Algebra 1. So a lot of times your answer is written as an ordered pair. So that's elimination. And on the other side, I'm going to do substitution. Same system, but just a different method. What's the first step on a substitution approach? Getting one of the variables by itself. So I have either x equals some mumble-jumble expression or y equals some expression so that I have something to actually substitute in and out. In this particular case, I've got the first x or the second x, the first y or the second y to solve for. Which one is definitely the right answer here? Which one of those 4 variables should I solve for? Which one, the first or the second? Because? Because it doesn't have a coefficient, right? Anything else, I'd have to divide everything by 2, by 3, or by 2, which would create fractions. And you don't want to have to substitute in fractions if you can avoid it, okay? Because nobody likes fractions, including me. So I'm going to get this y all by itself. So over here, I'm just going to rewrite that problem, and I'm going to add the y over and also subtract the 5 to the left. I kind of did 2 for 1 there. That's my 2 for 1 special you see right there. So we have that y equals this. Now that came from the first equation. So now I have something to substitute in for the y and replace the y with in the other equation. So I'm going to go to now the other equation, and I'm going to take out the y and replace it with this. So it's going to be 3x plus 2, and here the y is going to get popped out, and I'm popping in the 2x minus 5 equals 4. So what I now have that I didn't have earlier, I had 2 equations with 2 variables. By doing that substitution, I've now written one equation with one variable, which is now solvable. So I can just distribute. I'm going to combine like terms and add my 10 over all at once. And again, I'm going to get the same answer, x equals 2. And again, I go back to one of my originals, plug that in, and I'll get y equals negative 1. So regardless of the method, your answer should be the same. But just a quick review on systems. Any questions? Yeah.
If you check that, like the substitution on the first one, 2x minus y equals 5, you get positive 1.
If I check it, I'm not going to get the right answer?
Well, that's what I got, yeah. Because it's 2 times 2 minus y.
Minus a negative would be plus. So 2 times 2 is 4, plus 1 is 5.
Oh, why did I do that?
Okay, so it should work. When you go back and check your solution in both of the originals, they both should work. All right. This is there for you. I'm not going to bore you by reading it. I'm just going to show you by example here. So, 3 variables, you need 3 equations. Okay? Elimination is the only way I'm going to teach, because quite frankly, it's cleaner. So, just like the elimination we did before, look at your x's, look at your y's, look at your z's. Which one is it going to be easiest to get the same number in front of all of them? X's, y's, or z's? X's? Z's. X's would have to become a 6, right? And all 3 of them would need a multiplier. Y's would have to become a 12, and all 3 of them would need a multiplier. And on this one, they all can become 2's, and at least only the first 2 need to be multiplied by 2. Yes? So this is where the way I'm showing you and the way I used to do it, and perhaps your Algebra 2 teachers did it this way, might differ. Because they might just focus on the first 2 equations first, in which case you wouldn't need a multiplier at all. And then they would focus on the second 2 equations where you would need a multiplier. But to me, that leaves like a pocket of work for the first section, and then a different pocket of work somewhere else on your paper for the second elimination. And the way that I've kind of transitioned myself to teach it just makes it clean all the way across. So if I just get everything to be a 2 right off the bat, I can just rewrite all 3 equations still in line with each other. So 2x plus 8y minus 2z equals 40. 6x plus 4y plus 2z equals 16. And the third equation, I'm just copying over. So it's very, I mean, for someone trying to read and decipher through your work, I know exactly what just happened there. And then I'm going to do my first 2 equations, and I'm done with multipliers, so I don't have to take a time out to do that ever again. am I going to add the first two equations or subtract them? What do you think, Mike? Add. Is that what you said? Did you say it? Who said it? Oh, Brock did. Sorry, stole your thunder. Opposite signs add is correct. So plus, 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 plus. So this is going to become, and I have my little arrow showing me that these two equations together become an 8x. 8y plus 4y is 12y. Negative 2z plus 2z is gone. 40 plus 16 is 56. So there's new equation 1. And then right below that, because I've taken care of the multipliers already, all in the first step, I can do the second two equations. Which is, okay, Mike, I won't let him steal your thunder this time. Add or subtract on the second two.
Subtract.
Very good. Same sign because they're both positive, subtract. So here's, with the subtraction, you have to be a little bit more mindful of double signs tripping you up. 6x minus 2x is 4x. 4 minus negative 3, 7y. 2z minus 2z, gone. 16 minus negative 16 is 32. It's just so much cleaner. It's all kind of fluid. There's not like different pockets of work everywhere when you do, get everything to have the same coefficient right from the get-go. Now from here, you've got to kind of restart your thought process again because our z's at least are gone, and now we've whittled it down to 2 equations, 2 variables. 3 equations, 3 variables, came 2 equations, 2 variables. What's easier to get to be the same, the x's or the y's? For sure. I'm going to leave this one the same. And this one times 2. And because I'm working left to right, I obviously will eventually, if you haven't already, and now I have run out of room. Add or subtract, Carolina?
You would.
Is the same sign subtract or opposite signs add?
So 12y and 14y are the same, so you would subtract.
But we don't care about the 12 and the 14 because they're not what we decided to get the same number. We only care about the term that we decided to get the same number. 8 and 8 are same, both positive. Yes, so subtract. So you had the right answer, but it was a little bit coincidental. You don't want to look at the non-matching ones. So when you do your subtraction, and I'll just go down from here, 12 minus 14 is negative 2. Y equals negative 8. So y is 4. And then everything's just a domino effect backwards. So you go back to the previous level, and I'll use the 4x plus 7 times 4 now equals 32. Subtract 28 from both sides. 4x equals 4. X equals 1. And then we go back to an original where x is 1 and y is 4. So I'll do the last original. 2 times 1 minus 3 times 4 plus 2z equals negative 16. So I'll subtract this 2 over. I'll add this 12 over. Negative 18 plus 12, negative 6. Z equals negative 3. Now, even though these aren't lines, you still may see the solution written as your x coordinate, y coordinate, and z coordinate. Because there is such a thing. Right now, all you guys know about is a 2-dimensional plane, like with an x-axis and a y-axis. There is a 3-dimensional plane. What was that noise, Ryan?
We're getting into new dimensions? Like, what the hell?
No. First of all, watch your language.
What the heck?
What the heck is more appropriate? Second of all, don't feel defeated. Feel like, wow, that's really cool. How does that work? Well, let me show you. This is an x-axis still. This is a y-axis still. And a z-axis will give you depth. So if your x coordinate is 1 and your y coordinate is 4 and your z coordinate is -3, that would actually go backwards into the paper. It would be like a 3D like cube. I should show you an animation online because graphing 3-dimensional shapes on 2-dimensional paper is not very conducive. But anyway, that's it. Are there any questions? We're going to stop there for today.